Data warehouses have been helping companies to derive insight and analytics from their data right from the onset. It's been over 2 decades or 3 decades now that data warehouses have been helping businesses to derive insight and analytics. However, there's a recent shift in trend from batch processing to stream processing, and that means businesses that want to stay ahead of the game needs to start deriving insight and analytics as data comes in. You can no longer afford to wait for T-1 or T-7, that's yesterday's data or last week's data, to process them now so that you can get what is happening in your company or in your business. You need to know what is currently happening in the market as of this moment. While this is mostly applicable to businesses that is looking to get insight and analytics very fast, it is also very important to understand that existing systems can also be improved and can be adapted to leverage these insight and analytics in real time. Regardless of what industry you're working with, you can easily just switch over or incorporate the real-time analytics on the other side while focusing on the batch processing system and try to migrate and ease into the real-time streaming world. In this video, we are going to be going through some processes on how to set up your data warehouse from scratch. We're going to be doing some dimensional modeling where we have the dimensions and the facts, and we're going to be employing the schema, the star schema architecture, where you have the facts connecting to multiple dimensions, but it can be applied to a snowflake architecture as well. Now with that, we generate batch processing systems, load the data into the dimensions, and for the real-time streaming systems, it's going to be in our transaction table, which is a fact. With that, we couple everything together, and then we connect it to a visualization dashboard, which is going to be where we're going to be creating our dashboard, deriving some analytics and insights from there. And based on that, you can start seeing some value as data comes into the system, while you can still wait for the T-1, T-7, however you want it, but you can, going forward, start to dramatically shift your horizon from the old system, which is the batch processing approach, into the real-time streaming world. So let's get into the architecture of the system and get started with that. So taking a quick look at the architecture of the system, we have a real-time data warehouse architecture laid out for us on the screen. And we're going to have a financial institution, which is going to be a dummy financial institution that is going to be generating some data. And this data is going to be in the form of a star schema, which is going to have a dimension and a fact. As a result of that, we're going to load this into a DAG or some DAGs into Apache Airflow. Apache Airflow will be configured with Celery backend and Postgres as the DB. So as a result of that, you can also swap Celery out and use Kubernetes, or use local executor, any other executor that you prefer if you have a custom one. From here, we're going to be streaming data into Red Panda, which are the real-time data from Apache Airflow to Red Panda. The other bits, which are going to be the batch, which are the dimension tables, are going to be going and loaded directly with Apache Airflow into Apache Pinot. With that, we're going to be streaming from Apache Pinot into Apache Superset dashboard. All these will be taken care of in this video. With that said, we're going to start with the simple star schema architecture, where we have the dimension and the fact. I'm going to just display them just next to this architecture, and we can quickly discuss what the architecture look like in terms of the star schema architecture. So if you look at the star schema in this case, we have the transaction fact, which is the regular transactions that are coming into the system, which are the transaction ID, account ID, and stuff like that. And as a result of this, we are going to be dimensioning this into separate dimensions. So we have the dimensional modeling for the branch, which has this table, account has this, customer this, and the date dimension this. I've decided date dimension may be added if you want, but in my case, I just have it here for dummy's sake. I'm not going to be working with the date dimension in this case. But we're going to be having the branch, account, and the customer dimension all linking to this transaction fact. Because of that, we're going to have the account ID as a foreign key into this, the branch ID, the branch dimension, as well as the customer dimension. All these are going to be working together. So with that being said, let's go into the actual coding section, and we can get started with the coding part of this video. before we go into the coding part, we're going to be assuming that you already have Docker installed on your machine and you have reasonable compute to power some of these architectures. So I'm going to start by creating a new project. I'll call this Realtime Data Warehouse. And this is going to be in the PyCharm project. It's going to have a Git repository and then a welcome script to be created, which is going to be for Python 3.9. But you can change this if you prefer 3.10 or above. You can download and install, but I'll be sticking to 3.9. For some reason, I have preference for this. But this, of course, lacks some of the latest features in Python 3.12 or thereabout. Okay. With that said, let's create a new project and get started with that. So I'll just increase the font size a little bit, and then just remove the main here. We are not going to be needing this much. We are going to be just remove this. Now, according to architecture, we need to bring in some of these data into the picture. Let's start with Apache Airflow first. So Apache Airflow is going to be our Docker compose. So I'm just going to touch Docker compose.yaml. Okay. In that case, we're going to have a Docker compose.yaml here. And I already have the architecture in my notes, so I'm just going to copy paste that into that because it's a lot of typing to go into. So this is what it looks like. What we have right now is having a common file, which is a common properties here, which are the things that will be used by the different services by Apache Airflow. We're going to be using the Postgres DB as the database for reference purposes, this guy. And for this guy, we'll be using Celery. For some people that do not have enough resources, you might want to not use Celery, because for you to use Celery, you need to have additional Celery app, which is going to have a Celery worker as well. And then that's going to be additional overhead. But regardless of that, if you decide to use the full version of the architecture, I can point you to the right direction. And I'm going to just direct you to Apache Airflow page where you have the Docker Compose, which has the full Docker Compose information that you can use. So if you go to the Docker Compose YAML, I'm going to be dropping this link in the description so you don't have to worry about that. So if you click on the Docker Compose, you see all this information here. I've adapted this and removed Celery from here, so I don't have to worry so much about that. But if you decide to use this particular Docker Compose for your own project, then you are free to continue using that. But as a result of that, yeah, so you can copy paste this and replace the Apache Airflow bit of this architecture with this particular Docker Compose. Yeah, with that said, I changed this to local executor. I'm not using Celery executor in this case. I'm using Postgres 13, Airflow web server, which is the same thing I was using before, the scheduler, and the initialization. So as a result of that, you have the username and password for Apache Airflow, which is going to be, if you set this particular environment in the .env, it's going to use that. If you do not, it's going to use Airflow as username and password. Then we have the CLI, which is the common CLI. So these are some of the properties of the common environment. So we're going to be creating all these volumes, the logs, the DAX, the config, and the plugins that will be used. And I have a user of 5,000. I think everything here seems to be straightforward enough, and I can get started with this. So let's see if everything works fine. So do I have Docker started? I'm just going to start my Docker engine. So going back to our code, we have this, so I can just start the architecture properly. So once my Docker Compose, once my Docker engine is started, I'm just going to go back to my data warehouse application and then Docker Compose up in detached mode. This way, we have the Airflow UID. So let's touch .env and put in our Airflow.uid in there. So let's call this 1000. Whatever you call it should be fine. Okay, so I'm just going to start that. It says this refer to a Postgres unidentified code with you. Yeah, of course, I just need to go back to the network section here and add networks, and that will be code with you. Okay, that should be pretty straightforward. Yeah, and that fixed it. So we have Postgres, Airflow initialization, the web server, and the scheduler. Like I mentioned, bear in mind this is like a local or development environment architecture. So in the case you want to use production environment, don't forget to use the Celery one or the Kubernetes or wherever it is you're deploying to, so that you can have enough when you have enough resources to run these workloads. But in my case, I want to have a skinnier workload, so it still works just fine. It's just like it's not 100% suitable for production. Okay, so we have the scheduler and the web server started, and you can see what happens here. My initialization is done, the creation is also done, and you have the web server, which works just fine, and the scheduler as well, which also works fine. So if you want to check that out, you can go to localhost 8080, or what's that again? I guess I've just 8180. So I exposed the wrong port. Well, it's not wrong because I have something else running in my local host. So I'm just going to go to localhost 8180 and Airflow as my username and password, and we're good to go. So Apache Airflow is set up and is ready to rock and roll. And if you look on the left, we have those files, those folders and files that has already been created for us by the scheduler, by the DAGs processor, as well as the DAGs config and production and plugins. So that's the first bit of the architecture. The second bit is to get in the other part of the system, like the Apache Pinot, Superset, Red Panda into the picture. Okay, so in here we're going to start. We already taking care of this. Now we go into the Red Panda and Apache Pinot as well as Superset. So let's do that. So going back to this architecture, I'm just going to make way for these guys. So I'll copy in the Zookeeper, which is going to be the manager of our broker and the Pinot. So Zookeeper comes here into the picture, and I'm using Confluent Inc. CP Zookeeper 7.40. I'll be using Red Panda as my broker as well as the console, and that gets attached with Red Pandas. And I'll just come back just below here. I'll paste this here, and you can see just quickly run you through. I have my Zookeeper, I have Kafka Broker, I have the console, which is the Kafka Red Panda console. Yeah, and I think that works fine for Red Panda. This is working fine now. Well, we've not tested it, but it is assumed it is working fine. The next bit is the Pinot, Apache Pinot and Superset. But before we continue, let's see if everything works fine with Red Panda before we start that. So Zookeeper is started, the broker is started. Yeah, we have the console as well started. So let's see what that looks like. If you go into this guy, we have the console. If you go into localhost 8080, Red Panda is up and running. And yeah, so we have a single broker here. You can attach multiple brokers to that, but we're using a single broker with 0 topics in there, which is good. So that means Red Panda is also started. And if you look at the architecture we have, these bits have been taken care of. The next bit is the Pinot and the Superset. So let's get Pinot and Superset into the picture as well. So just below here, I'm trying to chronologically organize them. So that's why I'm scrolling up and down. I'm going to get in the controller, the broker, and the server for Apache Pinot. By the way, so you can have a fully fledged Apache Pinot deployment. If you read the documentation, there could be something more interesting than this, but I have my controller, my broker, as well as my server. These 3 will be facilitating the Apache Pinot architecture today. So as a result of that, I have my Pinot broker, Pinot server, the Pinot controller as well, which are all working just fine. So it's just a few seconds for the initialization or the loading to be done, and we can get started with Apache Pinot. Okay. So looking at this, for you to get started with Pinot, if you look at the Pinot controller, that's on localhost 9000. If I go to localhost 9000, yeah, that's still starting up. Let's wait for it. Okay, so the initialization is done, and let's see what that looks like on the dashboard. Localhost 9000 is hosting Apache Pinot, and on Pinot you have your cluster manager, which tells you and gives you the information of everything that you have running on your cluster. You have the query console where you write your real-time analytics query here and the aggregations. Then you have the browser, which tells you the cluster and the zookeeper information. This Pinot cluster tells you about the config, the controller information, some of the errors and information there. Yeah, a couple of information are there. That's not our focus in this video. But as a result of that, you have the tenant, one controller, one broker, one server. If you want to have a minion as well, you can use that, or the task queue. Nothing is running right now, and this is the cluster configuration. This by default is limited to false, set to false, but the rest is just fine. So if you look at the controller in itself, this is the simple configuration of the controller for the instance config, and this is live. Once it's live, but regardless of that, the configuration is not really the main focus of this video. It's just to get it ready with the default configuration, and we can get started with the rest of the code. Okay, now our code is ready to rock and roll, and everything seems to be working fine. So the first thing we want to do is getting the DAGs that will be fetching those information for our financial institution and sending them to Apache Airflow and then Pinot as well as Red Panda. Now, if this is your first time working with Apache Pinot, Apache Pinot works in such a way that you have, just like you have your data on your data warehouse, you have your data that is going to be sitting in a particular table, and this table is going to have a schema, right? So the concept of schema and table, which is usually coupled together in normal RDBMS, is decoupled in Apache Pinot. So you have to separately create the schema, then you create a table on top of that schema. So the table can now be like a real-time table, which is going to be coming, data is going to be coming from something like Apache Kafka or Red Panda. The other part is going to be like a batch upload, which is, so it's going to be loaded through batch uploads. So in the real sense of Apache Pinot, it is called two things. For real-time system, we call real-time, and for batch operated tables, you call them offline tables. Yeah, so those two concepts are very important because for you to have if you have a batch data, which is the offline table, in this case, you're not going to be uploading them or updating them regularly. It's going to be like once in 1 hour, once in a day, or once in a month, or however it is the frequency looks like. But in real time, it's going to be like listening to events that is happening on Kafka or Red Panda or any other broker that you're going to be connected to. So that's the main distinction between those two tables. You can have the same schema. Well, in theory, you can have the same schema for both real time and the offline, but it only makes sense. The table name is going to be different. They can be using the same schema but different table name. So the concept has been uncoupled. So we have separation of concern between the schema as well as the table. I'll show you how that works in real practice, so you don't have to worry if you do not get it once straightforward. I'll just show you how that works. So here, if you look at the table, we have a schema, we have offline table, and we have a real-time table. So let's start with a simple architecture, which is with the simple schema. So inside our DAGs, I'm going to create a couple of folders here. I'll create a first one. I'll call these schemas, and we have another one, tables. Now, these schemas is going to be, if you look at the architecture we have here, so we are going to create a schema for all of this, both the dimension and the fact where the data is going to be going into. We are going to have schemas, about 5 schemas in this case, and 5 tables. So four of the tables are going to be offline table, and the transaction fact is going to be a real-time table. Okay. All right, so let's go back to the code. So for the first one is going to be a schema of a JSON. So I'm going to have account dim schema, okay, .json. Yeah, don't ask me again, please add. And inside my dogs schemas, I'm going to have another one, branch dim schema.json. Yeah, and I'm going to have the last one, which is going to be customer dim schema, and the final one, which is the transaction fact schema. Okay, so in the real sense of it, if you want to add the date dimension to this as well, all you just have to do is create a new schema in that folder. Okay, so for the account dimension schema, based on what we have, I'll just copy paste that and explain through. So we have the schema as account dimension. So for this dimension, we have a dimension field spec, which are the account ID, account type, customer ID, just like we have in here. If you look at what we have, I'm just going to minimize this. If you look at what we have here, we have for the account dimension, we have account ID, account type, customer ID, opening date, status, as well as the balance. Balance in this case is a matrix, which means that it's going to be a double. But if you decide not to use it as a metric, that could be like your use case. But in my use case here, it's going to be a metric. Okay. So also, there's one thing that I want to share with you, which is Apache Pinot schema. So to show you how Apache Pinot handles the data that is coming into each schema, you have something like this, and this is what a sample schema looks like. But if you look at data type here, you have about a couple of them here, which is like integer, long, float, double, big decimal, Boolean, timestamp, string, JSON, and byte. A quick question that will come to your mind is timestamp is for both date and time. So whether you have time or not, it's going to have a timestamp. It's going to carry a timestamp. So in this case, your time will be 0000 UTC. But if it's a timestamp, you can have additional time in this case. If it is a date, you can have this, but it needs to have a 00 timestamp. Just, I feel like that will be something you probably would like to know. So that's why you are seeing date and is having a data type of timestamp. So let's do the same for branch dimension. I'll just copy that into the picture here and do the same for customer dimension. And the final thing is the transaction fact. Okay. Yeah, so running through the transaction fact, we have the transaction ID, branch ID, account ID. Where's the branch ID? Yeah, branch ID is here, but the location is yeah, account ID, customer ID, the transaction type, currency, the transaction amount, exchange rate, and we have transaction date. So these are the structure, and if you look at what we have here, we have about 3 or 4 major data points. So we have the schema name, dimension field spec, the metrics field spec, as well as the date time field spec. So if you have multiple date time fields, you are going to put them in this section of the JSON object, and then we do the same for the metrics field as well as the dimension field. So nothing extraordinary is happening in this bit of the customer as well as the dimension as well. So that's just it. I just want to quickly show you what that look like. Okay. All right then. So once we have the table, the schemas, then the next thing is to create the table. So we have separate tables that are going to be linked to each of the schemas. So we have, let's create one, account dim dot JSON, which is the table in this case. Maybe I can copy this a couple of times. Yeah, so this would be branch dim. Paste this again. That would be customer dim. And finally, we are going to have transaction facts. Okay. Transaction facts thing. Yeah, this is not a dimension, it's a fact. So transaction fact works fine. Okay. So I'll just copy and paste the table configuration. If you look at this part, we have the account names, like I mentioned, branch, account, customer, they will all be offline table because we have to upload them manually or batch upload them. I hope that makes sense. Yeah, so we upload them manually. So in this case, we have a single segment for that. If you want to increase the segment, you can increase the replication, but there's no need for that. The tenant is fine, table indexing is okay, and I'm going to be using, if I expand this a little bit, I'm going to be using some indexing column, just like you do on your RDBMS, like SQL Server, Postgres, and the rest. You index the column and you sort them. So it's easy for the system to automatically create the indexing as well by the time you are working with the table from the onset. The same thing happens to the injection config, which is the way the system is going to recognize the data that is going to be loaded into it. So in this case, you have the bash injection. So what that means is you have to manually upload into this particular guy. Then there's no additional metadata. So that's for the account dimension. So for the branch, we do the same, which is the branch name, literally the same thing with the exception of the indexing and sorting column. We have the customer dimension as well. I'll just copy paste this. And the final one is the transaction fact, which is a little bit different from what we had before. So for the transaction fact, we just have this something like this. Now, in this case, the structure is a little bit different. If you look at this is offline. And for the transaction fact, it's a real-time system. So I'm going to have a separate segment, the tenant, the table indexing config, and the ingestion configuration, including the metadata. So the rest are pretty much similar to what we had in the offline table, with the exception that in the ingestion config is going to be different. The table type in this case will be real time, the segment this for the transaction date, of course. The tenant, the table indexing, which is this column. We're using this as the index column and we're sorting by date. Now for the ingestion config, we're going to be having the real-time segment information, whereas we are decoding data from Kafka through JSON approach. The serialization happens that way, the class name, the stream type, the value type, just information about the broker that we're connecting to. So this is where we're connecting to on the broker level, which is the broker IP, the host name and the port, and the topic that we're going to be listening to on the broker. Yeah, the rest is pretty much the same. I'll just leave that as it is, and all this also will be available in the description in case you need to go through those schemas and tables manually. Now, with that being said, we now need to get in our DAGs, the proper DAGs for Apache Airflow. And in the real sense of it, these are just like the skeleton for getting our DAGs into the our schema and tables into the picture. We need to have the DAGs that are going to be running them, the Apache Airflow DAG, where we read the data from the schema and the table. And the approach that I want to take is I don't want to manually have, I don't want to have individual schemas and table as a separate DAG. So I'm going to have a simple DAG, just one DAG that is going to be reading from this folder anything that looks like a JSON object. So it's going to look through that and load them into Apache Pinot. I hope that makes sense. But in some cases, you might want to maybe have a separate process or the separate DAG for them. So I'll just leave them as they are. So let's create the first one, which is the our Python file, which is like count dim generator. Generator. So our generator is going to, we're going to have the generator in this case will be generating the file that will be used to load the batch data into account dimension. I hope that makes sense. But let me say that again. Account dimension is going to have like a CSV that we're going to be using to generate the data from for account dimension, so that we can load that into Apache Pinot. Okay, so we're going to start with a simple one. Import random, and then from Airflow, the operators, the empty, import empty operator. So we are seeing these scribbles and errors, and there's no IntelliSense simply because we installed Apache Airflow container. We don't have anything like that on our local system. So I'm just import pip install Apache Airflow into my system. So if you are using Windows, this may not be a luxury you can afford. You may not be able to install Apache Airflow as I'm doing right now. So this particular bit of the video is a luxury that is only afforded by Linux and Unix system. So maybe it's time for you to upgrade to Linux or Unix system. Anyways, that's a shade. Okay, so Apache Airflow is installed now. We have Airflow operators and we have the empty operator. The same thing will be happening to Airflow, the operators. Then we get in our Python operator, because whatever we're doing, we're going to be using the Python operator. Okay, most of the work we're doing is going to be done by Python operator. That will be operators. Yeah, I missed the IntelliSense. It's coming in now, so it's good. Okay. Now, we need to have a start date, which is going to be when the jobs are going to start running. So we're going to have our date time. So let's import date time. Import date time. In fact, I'll just say from date time, import date time, and we need the time delta as well. Yeah. So the date time is going to be 2024 to September 15. Okay. And the default args is going to be a JSON object or dictionary object, however you want to call it. The owner in this case is going to be Code with You or Data Mastery Lab, whatever you call it. Then depends on past, it's going to be false. And this is simply because if you miss a particular day, then it needs to run the previous day before running the latest one. And if the previous one fails, then it may not start, depending on the configuration. So we have the backfill, which is going to be false. So these two particular configurations usually work hand in hand. So if you miss a particular day, you can start from whatever date you missed or the last run date and fill up until today. But in the case where any of the backfill data is false, and you say it depends on the past. So if the previous past is false or it didn't finish execution, you may not necessarily start the current one. Okay. So to make things simple, let's have a simple number of rows. So let's say num rows is going to be 50 records, so which is going to be the number of records to generate. And where do we want the output file to be, which is going to be the output file path. Okay, so in this case, it's going to be account dimension. Let's call this account dim large data.csv. Of course, 50 is not large, but in case you need more, you can increase it. But yeah, to just reduce the workload and the overhead, I'll just be using something simple like that. We have generate random data and generate random data based on the number of rows. Okay. Or let's call this row now. Okay. So we don't use the same variable as before. So yeah, to make that make sense, we're going to be having, based on what we had, we have account IDs, which is going to be a set of arrays. Account types is going to be set of arrays. Statuses is going to be set of arrays as well. And customer IDs is going to be the same. Then balances the same, yeah, based on what we have in there. And then we have the opening dates. Okay, I hope that makes sense. I mean, I'm talking about all of this is what we have here. we're working with a account dimension. Okay, so to generate that, we just need to, let's have account ID. So everything is generated here. So the next thing is to generate the records into those and prefill those array objects. So in this case, we have account ID. It's going to be a function of a, let's say a, then the row number 05D. Okay, and we're trying to generate 5 records. So if you have let's say A0001, so that's like 4 zeros and 1, so that's A 4 zeros and 1. So that's what the structure we're trying to replicate here. So we have some unique data in there. So random.choice, yeah, we're going to have random.choice between the savings. Okay, let's call this a capital letter, savings as well as checking. Okay, and we have status. The status is going to be random.choice, and that's going to be the same as active and inactive. Okay, active and inactive. So if you have a separate logic, you can apply them here, but just to not complicate things too much, we're going to have a similar approach to the A, B, C. We have the C, then we have random, the random integer being generated between 1 and then 1000, and to generate that over 05D. The same thing, the length is going to be 5 records. Then the balance is going to be the round of random.uniform. So we have a uniform balance between 100 or 00 and let's say 10,000, 10,000.00, and that's going to be rounded up to 2 decimal places. Okay, then, so since we have account IDs and the rest here, the next thing is to now generate date time. So which is going to be datetime dot now, and then we have the random date. Okay, based on that, now minus time delta between the days of random dot rand int of 0 and 365. Okay, so it's just to like generate random dates between now and last year. I hope that makes sense. Opening date in milliseconds is going to be random dot, yeah, random date, yeah, dot timestamp. Just get the timestamp for that and multiply that by 1000. So we're trying to convert to milliseconds, so it's easy for us to say we are returning account ID, account type, the status, customer ID, the balance, as well as the opening date in milliseconds. Okay, so this is the function that helps us to generate a particular account. Okay, so where do we use this? We're going to be using this in a function called generate account dim data. So this is the function that helps us to generate that. So this particular function takes care of a single customer, but now we need to now have the function that's going to be generating multiple customers. So we're going to be starting at row number equals to 1, and then while the row number is less than the number of rows, which is 50 record, right? Oh, we start as 1, so yeah, it only makes sense to start less than or equals to. Yeah, so with the same thing is going to be replicated here. Just copy this. All right, and then this is going to be equals to generate random data based on the row number. Pretty straightforward, right? I'm just going to expand this, but we don't need the architecture for now. So now account IDs they'll append, of course. We append the account ID. The same thing for account types. They'll append account type, account what else again? Yeah, statuses. They'll append then status. Then customer IDs they'll append customer ID. and maybe balance as well. Dot append balances, is it? Dot append the balance. Okay. Then finally, opening dates. Dot append opening dates milliseconds. Good. Then we can just increase the row number plus equals to 1. As simple as that. All right. So the final bit is to now create a data frame on top of this, so it's easy. So we don't have pip install pandas. So we have df equals to pd.data frame. So we need to go up and import pandas. Import pandas as pd. Okay. Yeah, that should be fine. Data frame, and then we put in those guys here. Account ID as the key is going to be account IDs. Yeah, account type is going to be account types. Yeah, the same thing. Status is going to be statuses. You're getting the gist. Customer ID is going to be customer IDs. Then we have the balance, it's going to be the balances. And finally, opening dates, it's going to be opening dates. Yeah, finally. Okay, so once that is done, we have a data in data frame object. The final bit is to just write this to a CSV, df to CSV, and then we have the output file index equals to false. As simple as that. And we can just say print or log it if you prefer logging. Yeah, CSV file with this output file name with number of rows as being number of rows as being generated successfully. Good. So that's taken care of. Let's quickly format this and make it make sense. Refactor, optimize, and everything should be good. Okay, so pandas is installed, but why is this not indexing that? I don't know. I just quickly installed it. I think it's a PyCharm thing, so it's not a problem. Okay, so that's taken care of. Yeah, so the next bit is to have the same thing happen for branch dimension as well as the customer dimension. So I'll just copy the same logic into my branch dimension. So I'll just have touch dags, and inside that I have branch dim generator.py. Okay, and I'll just paste this. So yeah, finally, I think I just missed one step. Okay, so when we generate the data, we haven't attached this to any DAG. Yeah, we need to do that. Yeah, I think, yeah, we need to do that. So let's have with DAG, and we're going to be importing this from airflow.dag. We put this as the DAG ID is going to be account dim generator, and the default argument is going to be the same as what we brought in, default args, default underscore args. Yeah, then the description is going to be to generate account dimension. Yeah, large account dimension data in a CSV file. The schedule interval is going to be a time delta of 1 day. So if you prefer that, or if you have a separate configuration, so don't forget to add that to that. So start date is going to be the start date that we selected, and then the tags, if you prefer to use a tags, in this case I'll just call this schema. Yeah, let's leave it as schema, and this is going to be referred to as DAG. Okay, So that should be okay. Yeah. And then, based on this, we have our DAG that we can use now. So our start is going to be empty operator. And the reason for that is because I don't want everything. I just want to have like an entry point. That's the major reason why that is there. Okay. So empty operator is going to have a task ID of let's say start task. The next one will be the generator itself, which is going to be generate account dim account dimension data. It's going to be a Python operator. And then we have the task ID. Because I formatted it, it deleted those unused imports. So task ID is going to be generate account dim data. And the Python callable, of course, is going to be generate account dim data. Okay. Maybe there's no space between this. All right. There's no open and close bracket. Then finally, end. So the end is going to be empty operator as well, just like the start. Task ID is going to be end task. I'm just going to remove the space between this, and at the end of the day, I have my start, generate account dimension data, and the end. As simple as that. So that takes care of my account dimension, and a similar architecture is applied to my branch as well. So I'm going to change this to code with you, and I'm going to change this as well to 15. Let's see if I need to do anything else. Yeah, branch dim large data, and I have my cities, the regions, and the postcodes, which is here. I'm using the same logic, which is just in this case, I'm generating 4 decimal places, and have my branch information here, the branch IDs information. I generate the data, and then I write to CSV. The same way, I have my branch dimension, the start, the generate branch, and the end, which is as simple as it is. So let's reformat it, and that should be it. So the same thing happens for the customer dimension generator as well. I'm just going to create another one here, and this is going to be customer dim generator.py. Okay, and I'll paste this here. Yeah, so as simple as that. So this is going to be like first name 1, last name this, customer 1, and the rest like that. Nothing too serious here, so I'll just leave that as it is, and just reformat the file as well. Yeah, and anything else here? Yeah, I think that's it. So the same thing happens for the 3. So we have the account, the branch, and the customer. And if you go back to our DAGs and I do a refresh, we are able to see the account dimension, the branch, and the customer dim generator. So which is good. So this makes sense. Accessing your data just got a whole lot easier. Meet Devat ODBC drivers, your reliable, high-performance data connector that gives you seamless access to both databases and cloud sources. With over 20 drivers for database access, 50 cloud data, and more than 100 third-party integration, Devat ODBC drivers are designed to give developers and data analysts everything they need. And the good part, you can try it all out with a 30-day free trial. These drivers are built for performance. They deliver fast, efficient access to SQL and NoSQL databases while using fewer system resources. All this is thanks to real-time data caching and embedded SQL engine. Accessing cloud data is quicker and faster than ever. An additional plus is the deployment that couldn't be more simpler and more affordable. It's a standalone installation file, meaning there is no extra software or database clients that is needed. For larger organizations, You can easily deploy the drivers across hundreds of machines using silent install and OEM licensing. And the best part, DevOps ODBC drivers work seamlessly with the tools that you already have, like Oracle, MySQL, Power BI, Tableau, even Salesforce. If you are working on Windows, Mac OS, Linux, these drivers gives you full flexibility as they are cross-platform. They are fully Unicode compliant and let you access and modify data in any language from Latin to Chinese, and are both supported on 32-bit and 64-bit systems. And when it comes to compatibility, these drivers support all major data types and offer customizable mapping between your database and ODBC types. So why wait? Unlock the full potential of your data with DevOps ODBC drivers. For fast, secure, versatile, and with a 30-day free trial, you can experience the difference for yourself today. So the final bit, I think, is the transaction fact. But let's make it more interesting and run this to see if everything is working just fine or not. So in our case, we want to see if our account dimension is going to pick up the branch and the customer as well. So it takes a few seconds. I'll just turn on auto refresh so it can always pick up. Yeah. And then let's go into the account dimension. What do we have? It's not started yet. So let's start it. Okay. So that is started now. It's queued up and it's going to start at any moment. So the start task is done. Generate account, dim data. And this is said, let's check the logs. It said, yeah, file these with 50 rows have been generated successfully. So to check that out, you can go into any of the what's the name, these guys here, web server. So I'm going to go into the scheduler because it was the scheduler that ran it. If you go into the files and go into Apache Airflow account team, you can see it here as well. So let's do the same for the branch. Let's go back one step. The branch, let's start this guy up and start this other guy as well. Okay, so they are going to be running in parallel, and we now have, as we expect here, account is here, and any moment from now we should be able to see the branch as well as the customer dimension. Yeah, that's taken care of as well. You can see the branch and the customer, which is like 7 seconds ago, which is good. So that means at this point, everything is working as expected. No issues at all. So the next bit is to now get in our transaction facts into the picture. But before we do that, let's work with what we have on Apache Pinot. So I think that should be the other way around. Let's start with the facts first, and then we move away from Apache Airflow into Apache Pinot properly. Okay, so we have account, branch, and customer done here. So let's do the same for the transaction fact. Okay, so our transaction fact is going to be a Kafka object. So I'll just do Kafka. Not Kafka, it's going to be transaction fact generator. Okay, so here we're going to have from Airflow import DAG, and then from Airflow the operators .empty import empty operator. From here, we have a couple of ways we can proceed or forge forward from here. It could be a simple like a generator, just like we did in the account dim, branch, and customer dimensions. We can do this. We can do that. Just generate the data and send to Kafka. But where's the fun in that? In the real sense, when you get to production environment or when you want to implement this, you want to do this with hooks. So where you have a hook that is taking in some parameters and the hook is doing the right thing to do. So that's what we're going to be doing. So we're going to be creating a plugin for our Kafka producer that's going to be generating the data and sending that to our Kafka producer. So in the real sense, I'm going to have something like Kafka operator, which is going to be the operator name. So I'm going to be importing Kafka produce operator. Okay. Kafka produce operator. Now this is the operator we need to create. So in our plugin section, we just need to right click on this, create a new Python file, and create Kafka operator.py. Okay. Now in our Kafka operator, this is where we're going to be writing our custom hook. So I'm going to have from airflow.models import base operator, which is going to be what we're going to be using as our super class. So I'm going to have from airflow. Yeah, let's start with that. And then we have a class called Kafka produce operator. If I can only type operator, and this is going to be like a subclass for base operator. So we have an annotation called apply default. So apply default is going to be coming from Apache Airflow decorator. So in this case, decorator is going to be on our init function. Init. So we have self, and then we have our Kafka broker, which is the parameter that we're going to be passing to this operator. We have Kafka broker, Kafka topic name or topic name, whatever you call it. The number of records, call this num records. Let's default this to 100. Then any other arguments, args, then any other quags as well. Okay, as simple as that. Then we can just call our superclass and pass in the Kafka produce operator with the self in it, then initialize that with the quags and args. So this is going to be args and the quags. Yeah, quags, not quads. Okay, so with that, I'm going to have self.Kafka broker just for the parameters that are coming in so the class can recognize them. So Kafka broker, we have self.Kafka topic. It's going to be Kafka topic. Then self.num records. It's going to be num records. Good. Now, so that's the initialization function, and that would take care of our producer with the operator in this case. So let's create our generator function. So it generates transaction data. Okay, so I'm going to be having number of rows, row num. Yeah, with that I have the customer IDs, which is the same logic that applied to the customer IDs here. This guy, I'm going to be simulating that for the producer for the transaction as well. So this is going to be a list of objects. So I'm going to have customer with a string object of I, and I'm going to be filling that up with Z fill of 5. So we have like 5 records in the system. Then this is going to be for I in range of 1 and self.num records plus 1. I hope that makes sense. So it's going to be the number of records, in this case 100. Then we start from 1 to number of records plus 1 because range is exclusive of the last number. Okay, so we do the same for account and the branch. Account IDs, and then the branch IDs as well. Where is it? Branch IDs as well. So this is going to be account and this is going to be branch. Okay, yeah. And then for the transaction type, of course in production or when you are using this for real project, you are going to have the right data, so you don't have to be using dummy data in my case. So I'm going to have transaction types as different transaction types, which could be credit, debit, transfer, transfer, withdrawal, and the deposit. Okay, then the currencies that we support, currencies, it's going to be something like USD, GBP, and let's call this euro. All right. So those are the the currencies that we support. So we can get into transaction ID, which is going to be F of T and STR row number. All right, Z field 6, so 6 characters. Transaction date is going to be the date time dot now minus time delta, just like we did before, from date time import date time and time delta. So we have time delta, and that's going to be, this is going to be random.randint, yeah, random.randint, and that's going to be from 0 to 365. And we're going to just get the timestamp and multiply that by 1000 so we can get the milliseconds. 0 365, closing this bracket. Then outside of this bracket, just going to have dot timestamp dot, let me see, one bracket is missing. This second one is the time delta, and that would be dot timestamp, is it? Timestamp multiplied by 1000. Okay, so the integer is closing in on this. It should be outside, and we should be closing this bit. We have, let's see, date time dot now, then close this, yeah, so we can get a timestamp from this particular difference. So we have the now between now and 365, which is like 1 year before now. Get the timestamp of that, multiply it by 1000 and convert it to integer. Okay, so the account ID is going to be random.choice. It's going to be account IDs, the same thing. Customer IDs is going to be random.choice customer IDs. We have transaction type, it's going to be random.choice transaction types, should be transaction types. Okay, then we have the currency. By the way, this should be customer ID, yeah. Currency should be random.choice currencies. Then we have the branch ID, it's going to be random.choice branch ID, so we can select from there. And finally, transaction amount. It's going to be a round figure of random.uniform value between 10 and 10,000. Dot 0. Let's put dot 0 to this as well and round this to 2 decimal places. Then the exchange rate is going to be round the same way, random.uniform, and then we pass in 0.5 and 1.5 as the exchange rate to the base currency. So it is assumed USB will be the base currency. Any other thing will be like that, but it doesn't matter. You know, this is like a dummy data that you can always play around. Okay, once that is done, the final thing is to get into transaction object, and this is going to be an object of transaction ID. Transaction ID is going to be transaction ID. In fact, let me just turn on my GitHub Copilot so it can easily help me complete the rest. I have transaction date, account ID, customer ID, transaction type, currency, branch ID, transaction amount, and exchange rate. Thank you, Copilot. And that's it. Disable. Yeah. So once that is done, we just return transaction. So we have this function. Anytime you call it, it's going to generate the transaction for us. Okay. And the final thing, why is this? Yeah, no new line at the end. Yeah, that's all right. Then we have another function called execute. So as part of the hook that we're creating, in this case, we have a producer here. So the execute function is going to, anytime you pass in the operator, it's going to go into this execute function and initialize it, of course, and then go into the execute function to execute whatever it is you passed into it. So we have Kafka producer, which is going to be taken in Bootstrap server. And if you ask me where Kafka producer is coming from, that would be pip install Kafka Python. So to make this make sense, on our web server and scheduler, you just need to do pip install Kafka Python. You can do this in the requirement.txt if you prefer. Yeah. Pip install Kafka Python, so we don't run into issues. Okay, so yeah, that's done. Kafka producer imports from there, and then our Bootstrap server is going to be self.kafka broker, of course. Then value serializer to produce data into Kafka is going to be a lambda of json.dumps, and then we pass in the value, imports JSON. Yeah. JSON.dumps, then we encode this into UTF-8 format. Good. And that's our producer. So it's easy from here on out to produce data. So just do for row number in the range of 1 to self.num records plus 1. Okay. The transaction that you generate, transaction is going to be self.generate transaction data with the row number. Okay. And then producer will be sending that data, but send that data into self.kafka topic that you provide, and the value that will be used in that case will be transaction. As simple as that. So you can just say self.log.info send transaction, and you can pass in the transaction object into that. Okay, don't forget to do producer flush. Go self.log.info. This part is just pure ceremonial, so you don't have to do this part. So we have self.num records of transaction records has been sent to Kafka topic of the self.kafka topic. Good. Yeah, it looks like that's it for our producer. So let's go back to our DAG so we can finish up on the DAG, and this guy. So our Kafka operator, this is not going to resolve because the plugin directly is automatically added to Apache Airflow at runtime. So it may not necessarily resolve this by the time you are typing that, but it's all right. We have start date just like we had before. Let me just copy that bit. Yeah, just copy this bit and paste that. Import date time from date time. Yeah. So let's create our function for the DAG. So we're going to have with DAG as our DAG. The DAG ID is going to be transaction facts generator, and we have the default argument. It's going to be default args. Yeah. And then the description is going to be transaction fact data generator into Kafka. Then the schedule interval is going to be time delta. I need to bring this guy in, yeah, and the days equals to 1. Then the tags is going to be fact data, comma, and that's it. So let's just say as DAG. So we can just put this in as start. It's going to be equal to empty operator, and that's going to be task ID. Well, this is ceremony as well, so you don't have to add this. Just want to then generate transaction data. It's going to be Kafka produce operator, and this is going to take in task ID of what? In our case, if you look at the Kafka operator that we created earlier, it's taking in Kafka broker, num records and all that. So we can have all of these as arguments, okay? So we don't forget. Yeah, so our task ID is going to be generate transaction fact data. All right, Kafka broker in our case is going to be Kafka broker 9092, which is the advertised listener for our broker ID. Then the Kafka topic is going to be transaction facts, and the number of records is going to be, say, 100. Yeah, 100 is fine. And finally, we have our end operator. It's going to be an empty operator. Thank you, operator, and that's it. Task ID is going to be end task. Well, like I said, the start and the end, they're just ceremonial in my case. You don't need to add them. Only generate transaction data works just fine. Okay, generate transaction data and end. Okay, finally, that's it for our Kafka operator, and let's see what that looks like in the dashboard. Yeah, we're seeing this error simply because it says DAG is missing start date parameter. And when we have our default argument, we need our start date. Of course, it's going to be start date. It's going to be start date. I think, yeah, that should fix it. Good. We can see our transaction fact generator is here and it's sitting pretty nicely. So let's see if we start this and see if the data is going to be generated. Yeah, so generate transaction fact data. I'm going to just start this. All right. And on our Kafka topic, let's see if we have data generated into that. So it's sending data now, and it says all success. If you go to topic and you do a refresh, you see transaction fact. And as expected, 50 records have been generated. Rather, 100 messages have been generated. And you can see what that look like. Good. Which is the transaction amount, the exchange rate is this, and the transaction blah blah blah. Everything is working just fine. Now, based on the fact that we already created our dimension here, if you go to the DAX, we already created our dimension with the tables on. This is the generator. We've not really worked on the Apache Pinot. This is a good time for us to connect Apache Pinot to this so we can get this rock and rolling. Okay. So at this point, what we've just done is to generate the DIMs and the facts. The data that goes into Apache Pinot itself has not been worked on or generated. In the real sense of it, that means the schema for Apache Pinot, where all these are going to be sitting in, and the table that we're going to be querying, both real-time and offline tables, have not been created. So we need to have a single DAG that helps us to do that. So it's easy for us to generate the schema on the go, and the same thing for the tables as well. So let's see what that look like. In our code, if you go back to the code in Python, if you look at the second bit where we have the schema on the left here in the tables, and we have the schemas with the tables. So we just need to have one more or two. We have schema dag.py, and we have our table dag.py as well. So we can write our table dag.py. Okay, now for the schema, so basically what this does is to take individual records in the schema, run them through, and send them over to Apache Pinot. So by the time we run that DAG, all the JSON objects in the schema folder are going to be looped through, read, and then fed into Apache Pinot. The same thing happens for the tables as well. So going to the schema DAG, we're going to have a simple, let me copy the one we had here. So it's just like a copy paste here. Yeah, so we have, and the start date is going to be, yeah, start date. So we have with DAG, just like before. I just can just copy this bit. I guess I'm too lazy to type. So here we have schema. So this is going to be schema DAG, and this is the DAG to submit all schemas in a folder to Apache Pinot. Okay, then the schedule interval is 1 day, blah blah blah. Start date is fine, and then the tag is going to be schema. Good. And as well, for the data, we need to have a start, empty operator. Yeah, I know you're bored with this, start and end. So start task. Like, to be honest with you, I don't know, for some reason I just prefer to do this. It's not like it's best practice or something, but in some cases it's just something I prefer. It's a personal preference. And then we need to have a function, so that's going to be submit schema, and this is going to be a Pinot schema submit operator. So in this, just like we created a Python Kafka produce operator here, we are going to do the same for Pinot schema submit operator. And in this case, we're going to have task ID, which is going to be to submit the schemas. For the task ID, then the folder path is going to be where the folder is going to be sitting in, OPT, Airflow, DAGs, and then the schemas directory. Okay. If you're wondering how I got that, if you go into the OPT, yeah, Airflow, load up. Yeah, you see the DAGs and you see the schemas. All right, these are the JSON objects that are here. You can see them. Okay, so that's where I got the path from. Then the Pinot URL, which is the broker URL. So we have HTTP Pinot controller in the path of 9000 and / schemas. Okay, so that's the URL to Apache Pinot. Okay, the end task, and then simply start, submit, and end. So let's import this schema submit operator from import this. So that will be just like we did for our Kafka operator. So the Kafka produce, where is it? No, that's inside the transaction fact. So Kafka operator. So we just need to create an operator here, and we call that Pinot schema not generator, is operator.py. Yeah, and that will be the name that we give this from Pinot schema operator. Yeah, so the same way we created the hook for the producer, we need to do the same for the schema submit. All right, so from Airflow dot models import this operator, and then from class is going to be Pinot schema submit operator, which is going to be inheriting from base operator. Okay, and then apply defaults just like before. Apply defaults and import that default def init. Yeah, and then we get in the self the folder path just like we had here, then the Pinot URL, comma Pinot URL, then we have the args and quirks. Simple as that. Then we can call the super, and the super is going to be the Pinot, to submit that to Pinot, to the super class, Pinot schema submit operator self, and then we pass in the args and the quirks. Okay, and then self dot folder path is going to be folder path, no comma, and self dot Pinot URL is going to be Pinot URL. Good. And then finally, once that is done, we execute. So execute this, and we can now read the data from that folder that is submitted. So we have a try function, try except here. So it's going to be exception as E, and we can just say self.log.error, an error occurred, and the error is going to be a string, str of E. Okay, as simple as that. And in the try function, we can have, in the try block, I don't know why I keep saying try function. So it's in the, that will be schema file is going to be glob. So glob comes to the rescue here, and we just import glob. Yeah, import glob.glob. Glob. Hey, if I can only type glob. All right, self.folder path. Yeah, then plus anything that you see that looks like asterisk.json. Okay, so this is going to give us the folder path and anything that looks like JSON object. Okay, so when you see that, you do a loop through for schema file in schema files. So try to read the data. I'm just saying with open the schema file in the read mode. All right, as file. Once you read the file, I mean, this is pure Python, like reading the file, input and output operation. So we just have schema data is going to be file.read, and no double column there. Schema.read, then we define the headers. Let's define the headers and submit the post request to Pinot. All right, so that's going to be headers. It's going to be equal to JSON object of content type, and that's going to be application/JSON, and the response to that is going to be request.post. Just post this, and that will be to self Pinot URL. The headers is going to be the headers that we just passed into the picture, and the data that we want to use is going to be the schema data, and that's it. So we just need to check the response. If response.status code equals to 200, that means that's successful. We just say self.log.info schema successfully submitted to Apache Pinot. Let's call the name. Let's get the name. So that will be the schema file. Good. And else, if it is not 200, then self.log.error failed to submit schema, and that will be the response.status code. So we get the right status code, and the data that is attached to that. So response.text, response.text. Good. And just erase the exception, so it's easy to, so we can cancel, and it just doesn't give us false sense of hope. So say schema submission failed with status code response.status code. Yeah, I think that's all we need to do for our hook in this case for submitting the data into Apache Pinot. All right, so the next bit is to use this in the schema DAG, so we can easily use that. If you go back to the UI and check this again, you should see schema DAG attached to this particular. Yeah, you can see schema DAG as well. So what that means is easily we can replicate this for the tables as well. So for the schema DAG, I'll maybe just copy everything here, paste it here, and change this to table DAG. So instead of this, I change this to Pinot table submit and table submit operator. And I'll copy this table and replace that submit tables, and this is going to be submit table. Yeah, submit table, and yeah, so instead of this, it's going to be tables, and this is going to be tables. All right. So we just need to create a similar operator in this case. I'll just maybe that's the table DAG. Yeah, I'll just copy this, yeah, and paste it. So Pinot table operator, and I have here, I just change this to table operator, table submit, and that should fix that. And then in the instead of schema file, we have table files, and this is going to be table file, and this is table data. Yeah, and this is table file, and this is going to be table submitted, fit to submit table, table submission. Yeah, I think that's all we need to do. So do we have anything like schema in here? No. So that's good. So that's our Pinot table operator, and that's our table DAG as well. So that works just fine. And let's check. We should be able to see our table DAG as well. Yeah, it's not coming. Why is it not coming up? So we have still same DAG ID. So this will be table DAG, and that should fix it. Yeah. If you check this again, good. We have schema DAG and table DAG. Now, before we go into that, if you look at our cluster here and you look at the tables, we don't have anything in the tables and the schema. So let's take this for a spin and see if we are able to use this schema DAG to produce data. So start this. And let's see. So the start is started. This is queued up already, and it's trying to submit the schema. Yeah, that's running now, and that's successful. And if you look at Apache Pinot after successfully running that, you can see the dimensions have been created. So we have 5 dimension columns, 0 date time column, and 1 metric column for this. And in this case, we're in the transaction fact, we have the dimension column, the date time column, and the metrics column. Good. So let's do the same, just like that, for the tables as well. So table DAG, run this, and we wait for that to be successfully completed. Yeah, so that's running, and it should hopefully submit everything to, yeah, good, and that should be done as well. In any case, if you run into any problem or issues while trying to create the tables with Apache Airflow, all you have to do is click on the Swagger REST API and go to add a table here on the post for tables section. So once you drop this down, you see how to post the or create the table. So you can do that by creating a click on try it out and go into each of these tables in the JSON objects that you have under the tables. Just copy that and paste those into this block, and you should see table account deemed successfully added. We need to do the same for branch dimension. I'll paste that there as well. Then we do the same for, where are you, customer dimension. Copy this, and then in here I'll paste that in, execute. Hopefully that's working fine as well. And finally, the transaction fact, which is a real-time JSON object here. Just copy this, and for the table section for the real-time, I paste it here, and you just need to be sure that your Kafka broker list is fine, and make sure the topic that you're listening to as well is also fine. Just send this in, and that should be created as well automatically. So you can either use Apache Airflow for that, or direct Swagger UI with Apache, that is packaged with Apache Pinot. With each of these, you are good to go, and you can see that transaction fact is real time, the rest are offline. Now, with the real-time section, if you can see in our transaction fact, we have some transactions here. So we are expecting something like that to be inside our transaction fact in it. So if you go into the query section, query console, and you try to check transaction fact, you should be able to see the records that you have on Red Panda in here as well. So you can dimension these to say, let's say, limit 5 or something like that, and then run query, and you should be able to see the queries here very fast as well. You can also write a query to join multiple dimensions with the transaction fact. So based on these, you can easily perform real-time aggregations and real-time analytics on the data that is provided to you on Apache Pinot with effortless querying and aggregation. That works just fine. Now, you might be asking, what about the account dimensions, the branch, and the customer? I told you earlier that these parts are batch processing systems related, right? So in that case, we need to upload this manually. To do that, you need to do either of two things. So the first thing will be to either you send data via post request through the command line, or you use Apache Airflow that we've been using so far. That should be fine as well. So I'm going to do one of them. I'm going to load one of them with the terminal, and you can easily replicate the same process with Apache Airflow as well if you prefer. So let's switch over to that and see how that looks like. So with that being said, we switch over to the coding section, and we can load those data into Apache Airflow. If you can still recall, based on what we have in our scheduler, in the file section, we should be able to see those generated files. If you go to OPT Airflow, you can see we still have branch, customer, and accounts generated for us. So based on that, we can switch over here and create a DAG that helps us to maintain that. We can have DAGs and call this loader dag.py. Okay, so with the loader dag.py, what we just have to do is go into the loader dag and write the query just like we've been doing before. From Airflow, import dag. The same thing we need to bring in the bash operator here. From airflow.operators.bash, we'll be importing the bash operator, and then we need to bring in the time as well. From datetime, import datetime and time delta. Those two are very important. Now we just get the same structure as we had before. Just copy this and just paste it here. And yeah, backfill is false, but depends on past is false, and that's okay. So then we have the DAG code itself, which is the DAG. This takes in a couple of parameter. So in the loader DAG, I'm just going to call this DAG ID. It's going to be dimension ingestion. Let me call it dimension batch injection. Okay. And the default argument is going to be the default args. The description is going to be a DAG to ingest dimension data into, let's call it that. You can change the description if you like. Then the schedule interval is going to be daily. So daily, if you want to change that, you can adjust that depending on what your requirement is or what your need is. So the start date, we already have it in the default DAG, so that's okay. Then catch up is going to be false, so we don't need to catch up if we miss any date or something like that. We're good to go. So all we just have to do is change this as DAG, and then we can get in our queries in here. So I'm just going to have ingest account dimension. It's going to be bash operator, and then the bash command that will be used is going to be this. I'm going to copy paste that so I don't make mistake in the bash command, and that's going to be something you have to work with in case you want to do the same as well. So if you look at what I have here, so my file is inside Apache Airflow account dim large data.csv. The header in this case is a multi-part form data. That means we are sending a form object, which is where we can send in the file. And the URL is from ingest from file, similar thing that you have in the Swagger UI. If you go for ingest from file, just like this, you have a similar thing. So if you prefer, you can copy this code and you'll be fine as well. So I need to pass in the table name that I'm going to be importing the data into, which is account dim, and the batch configuration, just like you had here, is going to be input CSV, and the record reader prop delimiter is going to be pipe. So in my case, I just left it as so this has been converted to, I think this is Unicode format or something. So that has been translated to that. So if you want to do the same, you need to do a similar thing, that you'll be fine as well. And this is as a caveat here, this is not meant to be used in production or for large input files. So I would suggest you use a different approach to load the data if you are in production environment. So that's for the account dimension. We need to do the same or similar thing to ingest customer dimension, which is going to be a bash operator as well. And I'm just going to get the task ID in here, and that will be ingest account dimension. I'll just copy everything in here and just paste everything here and change this to customer. We need to change this to customer dim large data. Then in the part where we are loading into the table, we are loading into customer dim offline. I think that's everything we need to do in there. So the same way we can replicate this for the branch dimension as well. Ingest branch dimension and change this as well to branch. And finally, this is to branch, and this final guy here is going to be branch. Okay, so looks like we're getting there and everything seems to be working well. We've not tested it, but we have a confidence that this will be working fine. So let's get our task dependencies right. So which is ingest account dimension. Then you go into ingest customer dimension, and ingest branch dimension. If you prefer to run them in parallel. You don't have to specify this hierarchy. They can easily be displayed on the graph without doing this. So going back to this guy, we have dimension batch ingestion. So if I do a refresh, we should be able to see the dimension batch ingestion in there. So if I check this, and we have these three, if you look at the graph, they are like connected together. And this was what I was talking about when I said you don't necessarily have to have this hierarchy in place. So if you commented that and you refresh this, you see the three are running in parallel now. So if I start this, there's no dependency between the three, so they can just run in parallel at the same time. Okay, I'm just going to stop one of them. Hopefully I can do that, because before, yeah, I'll just stop this as failed. Yeah, and okay, before I could do that, yeah, it was ingested twice. So let's see what we have in the account dimension. Yeah, we're seeing 50 documents. So one of them did not complete successfully, which is a good thing. If you check the branch as well, you see that you have 50 documents as well, and in the customer you have 100. So it looks like one of them actually went through. If I try to order this, order by customer ID, and I run this, do we have any duplicates? We actually do not, so which is a good thing. So let's see if we order this descending order, we have 100 customers, which is good. So that means we have 100 customers, 50 branches, and 50 accounts. So yeah, so that's basically how you can run through the data ingestion. You can ignore this part. I had to shut down before it's completed. But what you have basically is the entire structure, which is being supported by Apache Airflow. So again, to go through what we just did, we created the schemas and then the tables that were used for creating offline and real-time data on Apache Pinot. Then we also went through data ingestion into the real-time table as well as the offline table. So that's basically how you can work with the Apache Airflow when you're working with the Apache Pinot. So the next bit now is to go over to Apache Superset and then get data ingested so we can start developing our dashboard. So let's do that and see how that looks like by the time we ingest data into Apache Superset. By the way, Apache Superset, just realized that I didn't give you a background on Apache Superset. Now, Superset is an alternative to Elasticsearch. So it works similarly, just like you would work with Elasticsearch. But the only difference is Elasticsearch is privately owned by the Elasticsearch team, while Superset is an open source tool. So with this open source capability, you're not bound to any major contracting. All you just have to do is make sure you're using open source license and you're good to go. So you're covered with the open source license. Okay, so based on what we have in the code here, you look at we have we stopped at Apache Pinot. Now this bit you can use Elasticsearch or any other similar tool, but in our case we'll be using Apache Superset. Now for Superset, all we just have to do is bring in our image for Superset. Now this gets a little bit complicated because Superset is a little bit complicated to set up with Apache with Docker Compose, and it has its own block of separate code. So what I'm going to do is to copy paste that code, so it's going to be faster and I can explain through how that works. Changing the user to the root and installing my SQL client and Apache Pinot DB. You might be wondering why we decided to use my SQL client and Pinot DB. I'm going to get into the nitty-gritty of this shortly, but for you to work with Pinot, you need to install Pinot DB, And if you have any other DB you want to connect to, like MySQL client, you need to do the installation here as well. The username and password for Apache Superset is going to be here. So if you decide to use a .env file with these variables, you should be fine. You should be fine by the time you add them, and those will override the configurations we have in here. Then the next thing is to use the Superset initialization, which is setting up the migrations and setting up the DB and stuff like that. Then we have the superset config.py, which is inside here. We get to that shortly, and then just copy it to the Docker and then change the user to superset and start the initialization. As simple as that. Now in the initialization, what we're doing basically is to create a username and password then with the user. So all the data in the environment variables that I discussed with you earlier will be used to create an administrator. And the DB will be upgraded, initialization will be done, and then we start the server. Okay. Then for the superset config, we are using template processing is true, and enable proxy fix is true, and then the secret key is my own random generated string, which is a super strong secret key. And finally, if you go back to the Docker Compose, you see that in the username and password, I'm using admin and admin as my username and password. So if you decide to use a different thing, you can decide to use that in the .env file, but that will be inside the superset directory, so we can recognize it from there. Yeah, I think that's all you need to do here. So we can fire this up and see what that looks like. Just do Docker Compose up in the detached mode, and this is going to pull the image into our local system. So just 1 sec, and then if you go to the dashboard, Docker dashboard, do we have superset here? So this is started, and this was done 8 seconds ago, which is good. If you go to the dashboard now, and let's see if that is working just fine. Yeah, it's still initializing, so let's see what that look like. So it just created the user admin, so it's trying to initialize the DB just now. Okay, so the DB initialization is done, and the service is started at 8088, which is the one we're listening to. If I refresh this, we should be fine. If you can recall, the username and password is admin, and then if I log in, you should see something like this. So with that being said, let's go to the dashboard, Superset dashboard, and see what that look like. Now you have the dashboard, the charts, the data set, then the SQL lab. Then you have the security, which is where we'll be focusing on the database connection to be able to connect to Apache Pinot. Now, the first thing is to connect to Apache Pinot as a DB. By default, you have these major 4 guys, which is Postgres, Presto, MySQL, and SQLite. And these are supported majorly because we installed, when we were doing the superset initialization in the Docker file, we installed the MySQL client. So this capability was enabled with MySQL client. Now in our case, we are using Apache Pinot. Now the reason you're seeing Apache Pinot in that case, because if you did not follow the same structure that I did, you will not be able to see Apache Pinot. But you are seeing that because I installed this capability here, which is this library. Just in case you have a different DB that you want to use. So if I select Apache Pinot and you don't know how to connect the DB, you can click here and you'll see a list of supported databases and dependencies. So all these are supported, but all you just have to do is copy this and paste it as part of the superset initialization in the Docker file, and you're good to go. Okay, now going back here, before I do that, Apache Pinot is already installed, but we need to connect to it. So we just have to copy this URL and go into Superset and paste that in here. So the broker URL is going to be our Docker here. So in our controller, where's our controller? Our controller is Pinot controller in 9000 port. Okay, so that's Pinot controller at port 9000. Then for the broker, that's Pinot broker at 8099. So Pinot broker at 8099. All right, so that's all we need to change in this case. The next thing is to test for connection. So drum roll, and you see the connection looks good. So I'm just going to connect to that. And once the connection is established, you see something like this as the last modified. Apache Pinot as the backend, and is exposed in SQL Lab, which is good. So if you go to the SQL Lab and you try to write select queries, so you can select the database on the left, the schema as well, and then the tables that are imported from there. For the fact transaction, you should see something like this, which is good. Then same thing on the account dimension, you'll see that I see the data here automatically. Okay, so the next thing is to just write a few queries to validate that everything is working fine, and then we can just from there start developing our dashboard. So now if you look at the transaction fact that we have in here, it looks like what is currently in the transaction fact. If you're familiar with this star schema, you need to join to the dimension table to get the details of the branch, the customer, and the account ID in this case. So what I'm going to do, I already prepared a query to save some time on that, and I'm just going to paste that in here. So I'm getting everything from the transaction fact and then bringing in additional column from the different joins that we have. So if I run this, I should be able to see the data. If you look at what I have here, I have the branch information. The branch name is here. Where are you? The branch name should be somewhere here. So it looks like for some of the records, the branch name is nothing is in the branch information. Yeah, branch 001, 002, and in the transaction facts, let's see, transaction facts, we have branch 010, 00. So the number of records for the branch is, in this case, 5. And when we were generating the branch information, let's see, the branch dimension generator, we had 4. So this should be 5. So I'm just going to try and rerun this branch dimension generator. Okay. And that's the reason why we're not seeing any record for the branch. So I'm just going to rerun this. And in the code, I'm just going to update my loader and then load a new record into the branch. Okay. And I'm just going to save this up and go to the dashboard. And in the loader, where are you? The dimension batch ingestion. We should see the branch here, and I'm just going to run that. So the branch can start ingesting the data into that. So that's currently running. And if you go to Apache Pinot to fix that, I need to go into the cluster manager again, into the tables, and then in the branch dimension, we should have two segments. So the first one was the old record. So I'm just going to delete that segment so I can have only the latest one in there. And in the branch dimension, if I select star from here, we should have data being generated into that. So let's see. Is that successful? Any errors? Yeah. So that's segment of 550. So let's see what segment we currently have in the branch dimension. .550. So this is currently updating. So all we just have to do, I'll try to reload this segment. It says it couldn't find this 550. Yeah, that's bad. Okay, so that should be loaded now. And if we refresh this, we should see a new segment. Yeah, so this segment is good and we have good data now. So yeah, if you go to the query console and check branch dimension, you should see 5 records here. And if you go into Superset and try to rerun the query, we should be good this time around. Yeah, so the branch information, and you can see that we have some information for the branches, and the reason for that is because our branch started from 1 to 50. Meanwhile, the records in the transaction is showing 1 to 100. So this is fine. I mean, we can run with this. This is more like not a foolproof method of doing things. It's just to show you exactly how you can work with this, but yeah, you get the point. Now let's go over. So what we need to do is create a data set based on this. I'm just going to create a new one and call this transaction facts combined, and then save and explore. Now with this data set, you can create charts from this. And to start with, based on what we have in here, so let's start with a simple one, which is to get the number of branches and probably the total amount each of the branch was able to generate or something like that. So let's say profitable branches. If you go into the branch name and you select, so all of these are in the table. So in fact, let's create a fresh chart, so that's easy. So a fresh chart, and here we're going to be selecting bar chart, and using the same data sets that we just brought into the picture, transaction facts combined. If you prefer to bring in the dimension tables as well, yeah, we're good to go. But in this case, I'll just bring in the for the bar chart, the x-axis as the branch name. Then for the metrics, I'm just going to use the transaction amount as the metrics, and this is going to be the sum. And you can create the chart and see what that look like. So you have individual branches from 1 to 50, what that look like. So let's see if we can sort this by and get the first 10 record. The first 10 branches. And we just need to sort this by the total, not this guy. We need to sort this by the sum of amount. So sort by the transaction amount, and in descending order. So we just sort this and we should see that we have the sum of transaction in descending order for the first 10 branches. So I'm just going to save this and call this top 10 profitable branches. If I save this up and I add it to a new dashboard, so we don't have any dashboard right now, so let's create one. Yeah, I'm just going to go into the dashboard and create a new dashboard here. I'm going to call this main dashboard. Okay. Yeah, I'll try to create a new chart based on that and save. Yeah, so yeah, if you go back here, I cancel this and save it again. You should see the dashboard here, and save and go to the dashboard. So you can see the top 10 profitable branches here. So you can do like additional formatting, like adding the label or the legends to this guy, just like you had here. You can add additional labels to each of them, but yeah, we're going to leave it at that. And we had an additional chart, so let's add additional chart. So let's say this is the total number of records. So in the transaction facts, create a new chart and call this count of star and create the chart. So you should see that we have 500 records in there, and say total records. Save and go to the dashboard. You see the total record here. Let's create additional one. So let's see the pie, this distribution of the records based on the currency that we have in the system. So if you go in there, you have the currency. Do we have the currency in here? Where are you? Okay, we don't have the currency. Yeah, we do. So we have the currency, and the metric is going to be the transaction amount. Yeah, we use the sum as well. And if you look at this, we have the USD, euros, and the GBP, and this will be the currency distribution. Okay, you can also add the, I'm just going to save and go to the dashboard, and then let's add one final one. Let's say additional pie chart, but we try to format this pie chart a little bit differently. So we have this account type, don't we? This is account type, and we want to see the share for each of the account type. If you prefer to use average, you can do that as well. So you can see we have savings, checking, and the null. Okay, so I can use this. Null has more information, so I can say account type distribution. Okay, but we want to format this a little bit to make it make more sense. So I can change this into customize, and just in here, you have the outer radius. If you prefer to use the donut, which is something like this, you can increase the inner radius and something like this. So let's say we show total, which is the total is 2.5 million pounds. And currency is going to be pounds. So let's add it as a prefix. So you see 2.45 million pounds. And if we increase the radius a little bit, so we have additional space in there, you should be good to go. So I'm just going to update the chart and save it into the dashboard. Okay. So finally, let's say we are done with this. We just want to edit the dashboard so we can reduce the sizes or increase it as probably as you would like it to be. You can do that. So I can easily just move this to the left and move this to the bottom of this guy. Okay, the same thing here, and the currency here as well. If I save this up, you will see we have something like this. So we can see the profitable branches, the currency distribution, and the account type distribution. Yeah, so if you have additional cards that you want to add to this, you can do that, but I think we're going to just take a pause on that so we can start refreshing the dashboard. So let's say we are refreshing every 10 seconds and save for this session. So every 10 seconds the data will be automatically refreshed and we should see new records in here. So if you go to the 10 seconds is good. It's refreshing that now. So let's go into DAX again, and for the transaction fat, we can generate new records. Yeah, I'm just going to log in again. Airflow. Okay, submit that, and in the transaction fat, so let's say we are generating new transactions. If you go into Superset again in the dashboard. This is our main dashboard, isn't it? So I'm just going to admin that. Admin. And this is logging us out because it looks like we're using a similar structure or something like that for Superset as well as the Apache Airflow. So it looks like the CSRF token is logging both of them out at the same time. So to fix that, you can use Safari. I can use Safari to log in Superset and Apache Airflow on my Chrome. Oh. So in this case, I'll just say admin. Okay, and I have my data here, which is 600 records. I can close this guy. And in this guy, I can try to rerun this again. Airflow. So we shouldn't be logged out anymore. So we just created additional records, which is 100 records again. And we should be able to see that on the dashboard. So while this is generating the transaction fat data, this is going to be refreshing every 10 seconds. Save for this session. So we wait for 10 seconds and then we should see a refresh happening. So if I just expand this a little bit, you can see the refresh is happening. We have 700 records now. And if you prefer to set the auto refresh to longer time, you can also do that as well. So we have 700 records now. If I rerun this again, Yeah, I just rerun that. We should see 800 records loading into Superset shortly. Okay, and that should be refreshing in 5, 4. Yeah, that's it. You can see we have 800 records. So you have a real-time dashboard here. Well, maybe not real-time, it's a near real-time dashboard. About 10 seconds is the best time you probably have with Superset to do refresh. But if you have something like Streamlit, you can have a real-time dashboard loading data directly into your system. And if you prefer to change the logic for transaction fact, so let's say we are changing transaction fact in this case, transaction fact generator, and we just keep generating the data. And this is going to be in our Kafka produce operator. We're generating how many records here? So this is 100 records. So we're generating 100 records here. So we can still leave it at 100. But what we're going to be generating in this case is going to be how many records by default. If you check the transaction fast generator, we're generating 100 records. So if you change this to, let's say, 1000, and we save that, and on the dashboard again, Airflow dashboard, and you do like a run of this, we should see 1000 additional record added to the dashboard in the next 10 seconds or thereabouts. Okay, so that's going on in the background, and this is also going to be adding 1000 records to what you have on the dashboard. So yeah. And interestingly, if you continuously run this data across the system, you can always have real-time data every 10 seconds. So you can see we have 1.28K. And so the number of data you have in here is growing as well. So yeah, so this is exactly how best you can work with the structure that we have in place. So based on this architecture, we've been able to satisfy this. So we're able to generate data with Apache Airflow, and we're streaming data directly into Apache Pinot and into Red Panda. And from Pinot, we are streaming into Apache Superset and visualizing data in real time. Well, in near real time, maybe not in real time, because 10 seconds is not necessarily a real time system. So it's a near real time system, which is still very good. Now, in our case, if you want to take this further and make it more robust in terms of the architecture, you can add additional capabilities or increase the compute. Obviously, I struggle a little bit with compute because of the architecture I'm running. So in the case where you want to run this in production environment, you necessarily you need to have something like Celery in the backend, Redis as well, going for the full architecture in this case. And for that, you have Apache Airflow being semi-ready for production. You still need to fine-tune the configuration based on your need. And once that is done, you can easily connect to Apache Pinot, set it up in a more productionized way, and you can get some help with that from the Apache Pinot community. You have Red Panda as well, which is by default a good broker. So, but in terms of production, you might not want to have a single broker. Multiple brokers increase your resilience and high availability. When you have Apache Superset as well, data going into Apache Superset, you can easily visualize them. And you can, increase the capability of Apache Superset, so increase resilience, and in case of downtime, everything can still continue as expected. So thank you very much for watching this video. Don't forget to like, comment, share, and subscribe, and I'll see you in the next video.